In this video, we are answering questions based on circle theorems from Theorem 1 to Theorem 9. For each theorem, we have two examples, and we're going to start with Theorem 1. Theorem 1 says that the line segment drawn from the center of the circle to the midpoint of a chord is perpendicular to the chord. A chord is a line segment that has its two ends on the circumference of the circle. You have to note that a chord does not pass through the center of the circle. If it passes through the center of the circle, then it is not a chord, but it is a diameter. In the first example, in this theorem, we are given that the radius is 5 units and BC is 8 units. We are looking for the length of AM and the length of OM. According to this theorem, a line from the center of the circle to the midpoint of a chord is perpendicular to the chord. It is indicated to us that BM is equal to MC, which makes M the midpoint of BC. So if the line OM meets the chord BC at the midpoint, then OM is perpendicular to BC, and this is a 90 degrees angle. A radius is a line from the center to any point on the circumference of the circle. This line is from the center to the circumference of the circle. Therefore, it is a radius and it has a length of 5 units. The same applies to OC. OC is a line from the center to the circumference of the circle. Therefore, it is also a radius and it has a length of 5 units. If BC is 8 units and BM is equal to MC, then BM is equal to 4 units and MC is also equal to 4 units. So now that we have this information, we know the length of OC and we know the length of MC, we can now use the Pythagoras theorem to find the length of OM. The side that is opposite the 90 degrees angle is OC, which is 5, and MC is 4 units. 5 squared is 25 and 4 squared is 16. 25 minus 16 is 9. Then we square root both sides of the equal sign to make it simple. Square root of 9 is 3. So the length of OM is 3 units. AM is the length of the radius plus the length of OM. OA, which is the radius, is 5 units, and OM, which we just calculated, is 3 units. 5 plus 3 is 8, so the length of AM is 8 units. Let's move on to the second example. We are given that PR is 8 units, the radius is 10 units, and OQ is perpendicular to PR. We are looking for the value of X. This theorem states that a line segment drawn from the center of the circle to the midpoint of a chord is perpendicular to the chord. The fact that we are already given that OQ is perpendicular to PR tells us that the line OQ meets the chord PR at the midpoint, and the length of PQ is equal to the length of QR. So if PR is 8 units, then PQ is 4 units, and QR is also 4 units. A radius is a line from the center to any point on the circumference of the circle. The point O is at the center, and the point P is on the circumference of the circle. Therefore, OP is a radius and it has a length of 10 units. We can now use the Pythagoras theorem to find the value of X using this right-angled triangle. We are looking for OQ, so we make it the subject of the formula. The length of OP is 10 and PQ is 4 units. 10 squared is 100 and 4 squared is 16. 100 minus 16 is 84. The square root of 84 is 2 root 21. So the value of X is 2 root 21. Theorem 2 states that The angle which an arc of a circle subtends at the center of the circle is twice the angle it subtends at the circumference of the circle. In other words, the angle at the center is twice the angle at the circumference. We're going to be doing 3 examples in Theorem 2 because I want you to get clear understanding in different examples. All you need to understand in this theorem is the angle at the center and the angle at the circumference. In the first example, we are given the angle at the circumference and we are looking for the angle at the center, which is the value of b. If the angle at the center is twice the angle at the circumference, and we have a 45 degrees angle at the circumference, to find the value of b, we multiply 45 degrees by 2, which will give us 90 degrees. So the value of b is 90 degrees. In the second example, it is indicated to us that AO is parallel to BC. When two lines are parallel to each other and you have this shape, then these two angles are alternate angles and alternate angles are equal. So in this case, angle O is equal to angle B. They are alternate angles. And angle A is equal to angle C. They are also alternate angles. Theorem 2 states, the angle at the center is twice the angle at the circumference, and we are given the angle at the center, which is 70 degrees. To find the size of angle C, which is the angle at the circumference, we divide 70 degrees by 2, which will give us 35 degrees. We are looking for the value of x, which is angle A, and we know that angle A and angle C are alternate angles, and alternate angles are equal. So if angle C is 35 degrees, then angle A is also 35 degrees. In the third example, we are given the angle at the circumference, which is 100 degrees, and we are looking for the angle at the center, which is the value of D. We multiply 100 degrees by 2, which will give us 200 degrees. So the value of D is 200 degrees. Theorem 3 states that the angle subtended at the circle by a diameter is a right angle. We say that the angle in a semicircle is equal to 90 degrees. So we say this angle is an angle in a semicircle. The angle in a semicircle is formed by two chords that are drawn from the two ends of a diameter and meet at one point on the circumference of the circle, forming a 90 degrees angle. Whenever you have a diameter and you have two chords that are drawn from the two ends of a diameter and meet at one point on the circumference of the circle, then you have to know that the two chords form a 90 degrees angle at the point of contact. It doesn't matter at which point on the circumference of the circle they meet, as long as they are drawn from the two ends of a diameter, they form a 90 degrees angle from each other. Whether they meet at this point, or this point, or that point, or this point, as long as they are drawn from the two ends of a diameter and meet at one point on the circumference of the circle, they form a 90 degrees angle from each other. When we take a look at the first example, angle H is formed by two chords that are drawn from the two ends of a diameter and meet at one point on the circumference of the circle. Therefore, it is a 90 degrees angle and it is an angle in a semicircle. The sum of the angles in a triangle add up to 180 degrees. So to find the value of E, we minus 90 degrees and 35 degrees from 180 degrees, which will give us 55 degrees. So the value of E is 55 degrees. In the second example, this whole angle is a 90 degrees angle. It is an angle in a semicircle. It is formed by two chords that are drawn from the two ends of a diameter and meet at one point on the circumference of the circle. To find the value of x, we minus 42 degrees from 90 degrees, which will give us 48 degrees. So the value of x is 48 degrees. Theorem 4 states that an arc or a chord of a circle subtend equal angles at the circumference of the circle. We say that the angles in the same segment of the circle are equal. In this theorem, we are looking at this shape. As long as these four corners lie on the circumference of the circle, then this angle is equal to this angle, and this angle is equal to this angle. In the first example, angle L is equal to angle K, which is the value of C. These two angles are in the same segment of the circle. Therefore, the value of C is 24 degrees. The exterior angle of a triangle is equal to the sum of the interior opposite angles. These two angles are equal to this exterior angle. So the value of C plus the value of D is equal to 102 degrees. We already know the value of C, which is 24 degrees, so we solve for D by taking 24 degrees to the other side of the equal sign. 102 degrees minus 24 degrees is equal to 78 degrees, so the value of D is 78 degrees. Angle M is equal to angle J, which is equal to 78 degrees, and the reason is they are angles in the same segment of the circle. In the second example, it is indicated to us that DE is parallel to GF. Therefore, angle E and angle G are alternate angles, and alternate angles are equal. So angle E is also equal to 35 degrees. We have this shape and we have all the four corners lying on the circumference of the circle. Therefore, these two angles are in the same segment of the circle, and according to Theorem 4, angles in the same segment of the circle are equal. So x is equal to angle E, which is equal to 35 degrees. Theorem 5 states that the opposite angles of a cyclic quadrilateral add up to 180 degrees. A cyclic quadrilateral is a four-sided shape that has all its four corners lying on the circumference of the circle. So as long as you have a four-sided shape and all its four corners lie on the circumference of the circle, it is a cyclic quadrilateral. This angle plus this angle add up to 180 degrees, and this angle plus this angle add up to 180 degrees. To find the value of B, we know that B plus 106 degrees add up to 180 degrees. Then we group the like terms by taking 106 degrees to the other side of the equal sign. 180 degrees minus 106 gives us 74 degrees. So the value of B is 74 degrees. The same applies to finding the value of A. We know that A plus 87 degrees add up to 180 degrees. Then we group the like terms by taking 87 degrees to the other side of the equal sign, which will give us 93 degrees. So the value of A is 93 degrees. In the second example, angle U plus angle W add up to 180 degrees. Then we group the like terms by taking 86 degrees to the other side of the equal sign, which will give us 94 degrees. So the size of angle W is 94 degrees. Now that we have the size of angle W, we can now find the size of angle A. This is a triangle, and we know that the sum of the angles in a triangle add up to 180 degrees. So to find the value of A, we have A plus 94 degrees plus 57 degrees is equal to 180 degrees. 94 degrees plus 57 degrees equals 151 degrees. Then we group the like terms by taking 151 degrees to the other side of the equal sign. 180 degrees minus 151 degrees is equal to 29 degrees. So the value of A is 29 degrees. Theorem 6 states that an exterior angle of a cyclic quadrilateral is equal to the interior opposite angle. So as long as you have a four-sided shape and all its four corners lie on the circumference of the circle, then the exterior angle is equal to the interior opposite angle. Therefore, this angle is equal to this angle, and the value of x is 110 degrees. In the second example, this is a four-sided shape and it has all its four corners lying on the circumference of the circle. Therefore, this is a cyclic quadrilateral and the exterior angle is equal to the interior opposite angle. So the value of A is 114 degrees. Theorem 7 states that a tangent to a circle is perpendicular to the radius at the point of contact. A tangent is a line touching the circle at only one point, and the radius is a line from the center to any point on the circumference of the circle. So as long as a tangent and a radius meet at one point, then this is a 90 degrees angle and this is a 90 degrees angle. To find the value of x, we know that this is a 90 degrees angle, so we minus 35 degrees from 90 degrees, which will give us 55 degrees, so the value of x is 55 degrees. This line passes through the center of the circle and it is 2 times the length of the radius, therefore it is a diameter. This angle is subtended at the circle by diameter, therefore it is an angle in a semicircle and it is equal to 90 degrees. So the value of y is 90 degrees and the reason is it is an angle in a semicircle. Now that we know the size of this angle and we know the size of this angle, to find the size of angle W, we know that the sum of the angles in a triangle add up to 180 degrees. So we minus 90 degrees and 55 degrees from 180 degrees, which will give us 35 degrees. So the size of angle W is 35 degrees. In the second example, this is a tangent and this is a radius and they meet at one point. Therefore, this is a 90 degrees angle. To find the value of x, we know that the sum of the angles in a triangle add up to 180 degrees. So we minus 90 degrees and 50 degrees from 180 degrees. So the value of x is 40 degrees. Theorem 8 states that if two tangents are drawn from the same point outside of the circle, then they are equal in length. A tangent is a line that touches the circle at only one point. So if two tangents are drawn from the same point outside of the circle, then the length of RS is equal to the length of QS. In the first example, we are given the length of RS, which is 3 centimeters, and we are looking for the length of QS. These two tangents are from the same points outside of the circle. Therefore, RS is equal to QS and the value of F is 3 centimeters. When we look at the second example, we have two tangents that are drawn from the same points outside of the circle. So we know that the length of AT is equal to the length of BT. We have a triangle ABT. And we know that these two sides of this triangle are equal. The properties of an isosceles triangle are two sides are equal and the base angles are equal. So this angle is equal to this angle. To find the value of A and B, we know that the sum of the angles in a triangle add up to 180 degrees. So we're going to minus 50 degrees from 180 degrees. If we minus 50 degrees from 180 degrees, we are left with 130 degrees. These two angles are equal, so we divide 130 degrees by 2, which will give us 65 degrees. So the value of A is 65 degrees and the value of B is 65 degrees. Theorem 9 states that the angle between its tangents to a circle and a chord drawn from the point of contact is equal to an angle in the alternate segment. As long as this is a tangent, then this angle, which is an angle between a tangent and a chord, is equal to this angle, and this angle is equal to this angle. So the value of G is 47 degrees, and the value of F is 38 degrees. When you take a look at the second example, this angle is between a tangent and a chord. So this angle is equal to angle S, which makes the value of A equal to 33 degrees. It is indicated to us that this line is parallel to this line, and we have this shape. Therefore, these two angles are alternate angles, and alternate angles are equal. Therefore, the value of B is also 33 degrees. Thank you guys for watching. I would like to know where you find a challenge in this chapter, so please leave a comment and watch more videos on this channel. We'll see you on the next video.